When GPS receivers were first manufactured in the early 1980s, they were big, expensive and heavy. Organisations could often only afford to buy 2 or maybe 3 and had to share resources. They were used for often large geodynamic projects for plate tectonic studies or earthquake studies in a campaign style mode. So what that means is that certain points would be surveyed on either side of a tectonically active region, and you would measure these points 1 year and come back a year later and measure them again and try and detect the motion. I was lucky enough to be working for an organisation in the US who were coordinating these projects, and we would fly into a country, we would bring all of our gear with us, train the local operators, deploy, measure, pack up the gear and get out again. It was a great job, but the holy grail was to catch an earthquake as it happened. In 1992, we missed out on the Landers earthquake, and a decision was made at that time that why don't we mount permanently a GPS receiver and leave it to run continuously. Hence was born this idea of continuously operating reference station networks, or CORS networks as we call them. These days, CORS networks have expanded much further. They cover whole nations, and not only for tectonic studies anymore, now we use them for a whole bunch of different applications. Professor Chris Rizos from the School of Surveying and Spatial Information Systems heads up the Geodesy Infrastructure and Analysis Research Group. He's also heavily involved in the International Association of Geodesy and the International GNSS service. So Chris, what is the GIA?
GIA stands for Geodetic Infrastructure and Analysis, and it's really a concept where we bring together the different components of modern geodesy. The technologies of satellites, the GPS satellites, the gravity mapping satellites, the altimeter satellites, the atmospheric remote sensing satellites. That's complemented by a ground network of thousands of GPS reference stations, but also satellite laser ranging stations, radio telescopes. And they work in an integrated fashion to make measurements to those satellites, to determine the satellite orbits to high accuracy, but also to determine principally the coordinates of those ground stations and how they change with time.
So Chris, how do all of the elements combine together?
Well, you have the ground stations basically tracking the satellites, making measurements, principally measurements of distance. And from that we're able to derive the various parameters of interest in geodesy. The coordinates of the satellites, but also the coordinates of the ground. And these are computed to very high accuracy using sophisticated software.
So Chris, what are the applications then of CORS networks?
Well, the applications range from the scientific applications, which of course is a fundamental mission of geodesy. That is, we want to know what the size and shape of the Earth is, but also how it changes at the centimetre level and even below the centimetre level. These changes are due to the fact that the Earth's surface is changing all the time due to crustal motion, also due to local fault motion, due to earthquakes, volcanic activity, ground subsidence, even sea level rise. But at a pragmatic level, the applications are that we use the same network to also support high precision positioning for farmers and their machinery, for miners, surveyors, mappers, navigators, and many other applications which are expanding every day.
So Chris, what are we doing up here?
Well, we're here on top of the electrical engineering building to see one of the reference stations that the university is running.
So is this the antenna just here?
Yes, it is. This is an antenna that can track the GPS satellites, the signals from the GPS. The data then goes down the cable into a receiver downstairs. And all the satellites which are above the horizon can be tracked using this antenna. These are typically installed 10, 20, even hundreds of kilometres apart. So you will not be able to see them obviously with the naked eye, but there are stations, probably a dozen stations within the Sydney Basin area. What we want in the future is many more stations, automated processing, continuous processing, in an ad hoc fashion, coming and going, coming online and offline, much like a wireless sensor peer-to-peer ad hoc network would be. This means that we will have a system, an observing system, a global observing system, that will be able to make measurements continuously of tens of thousands of points on the surface of the Earth.